Assalamualaikum warahmatullahi wabarakatuh, and a very good day to our lecturers, Azri, and also to our fellow classmates of Chemical Engineering. We are from the Chemical Engineering Group 2, and for our virtual collaborative discussion, we are assigned a tutorial question in which it talks about diffuser. So for our presentation, we will talk about a schematic diagram of a diffuser, the function and the application of a diffuser, and also the solution to our tutorial question. In this group, there are 5 people who contribute to this project, which is Aina Charamti Azizul, Amil Aiman Bernardin, Leksha AP Krishnamurti, Yap Shandi, and also me, Siti Radafina, Binti Rasulza, Elijah Rusli. Hi, my name is Siti Radafina, and for my part, I took a diffuser schematic diagram. So we all know that a diffuser is a device that increases the pressure of a fluid by slowing it down from this slide. So in every diffuser, the outlet velocity will always be lower than the inlet velocity in order to serve its purpose to increase the pressure. And we all know that in a diffuser, there are only one inlet and one outlet. Therefore, our mass flow rate at inlet and at outlet is the same, because this is according to the principle of mass conservation. And from this schematic diagram also, we can see that each info from the schematic diagram is taken exactly from the question tutorial, which is at the inlet, we have the pressure 1 is equals to 100 kilopascal, temperature 1 is equals to 27 degrees Celsius, and our velocity is our 220 meter per second. And then at our outlet, we don't know our P and we don't know our V, which will be exposed in our solution section later. But we all know that in the outlet we have the temperature, which is the 42 degrees Celsius, and the exit area is 400 centimeter square.
So for the next part, Aiman Binodin will explain about the function of diffuser. So there are two functions of diffuser. The first one is its purpose is to reduce the velocity of the flow leaving the impeller, resulting in an increase in pressure. The second one is to reduce the velocity and increasing the static pressure of a fluid passing through a system. Now I will explain about operation principle of diffuser. As air leaves an axial flow compressor and move toward the combustion section, it is traveling at speeds up to 500 feet per second. This is far too fast to support combustion, therefore the air velocity must be slowed significantly before it enters this combustion section. The divergent shape of a diffuser slows compressor discharge while, at some time, increasing air pressure to its highest value in the engine. The diffuser is usually a separate section bolted to the rear of the compressor case and ahead of the combustion chamber.
My name is Aina Atira, so I will be presenting for the next part, which is application of diffuser in our real life. First point is HVAC system. Common in heating, ventilating, and air conditioning systems, diffusers are used in both all air and air water system as part of room air distribution subsystem, and it serves several purposes. There is 4 functions of diffuser in HVAC systems. It is used to deliver both conditioning and ventilating air, evenly distribute the flow of air in the desired directions, to enhance mixing of room air into the primary air being discharged, and to reduce the velocity of the flow leaving the impeller, resulting in an increase in pressure. In this slide, I will explain how diffuser in HVAC system works. When air blows directly out of your ductwork and through a register or grill, it is either being directly pushed out or down. Once installed, an HVAC diffuser will cause the air to spread out evenly in multiple directions, which allow for even distribution. Plus, a diffuser is also beneficial for the reduction of noise with a properly designed system.
I'm Leksha, and today I'll be presenting about aircraft gas turbine engine. What is the function of diffuser in aircraft gas turbine engine? Diffuser is the divergent section of the engine after the compressor and before the combustion section, as you can see from the diagram. It has the function of releasing high velocity discharged air to increase the pressure at slower velocity. Next will be, how does the diffuser work? The diffuser slows down the compressor delivery air to reduce flow losses in the combustor. This prepares the slower air for entry into the flame burning area so that the flame of combustion can burn continuously. If the air is passed through the flame area at a high velocity, it could extinguish the flame. Slower air is also required to help stabilize the combustion flame, and the higher static improve the combustion efficiency.
My name is Yashan, and I'll be the presenter for tutorial question number 2. This question is related about the diffuser. This diagram already write all the important information given by the question. For the inlet, the pressure is 100 kPa, and for the temperature is 27 degrees Celsius. For the velocity is 220 mph. While for the outlet, the temperature is given, which is 42 degrees Celsius. However, we need to determine the pressure and also the velocity. The inlet mass flow rate and the outlet mass flow rate will be the same, which is 3.5 kg per s, as there is same hole for them to in and out. For the heat loss is 25 kJ per s, and the exit area will be the 400 cm3. I made 5 assumptions for this question. The first one is the diffuser is under steady flow process since there is no change with time. The second assumption is the diffuser is non-adiabatic. The third assumption is air is an ideal gas with constant specific heat. The fourth assumption is there are no word interaction. The last assumption is potential energy changes are negligible. Now I will explain about the overall energy balance in this question. The equation number 1 is the general equation can apply in all the system. The energy inlet minus energy outlet equal to delta E system. We cancel out the delta E system in this question because we assume it is a steady process. Therefore, we can get the equation number 2, which is the energy inlet is equal to energy outlet. The energy inlet can be replaced by Q net minus W net, and the energy outlet can be replaced by delta U plus delta KE plus energy in, and also the energy out. We can get the final equation, which is this. Now I will explain about step to get solution. This equation is I will apply to get the axis velocity. As there is only one inlet and one outlet, I assume the M1 is equal to M2, which is 3.5 kg per s. The question already mentioned is air, therefore we can referring to the table S70. So we can see that the temperature is under Kelvin as a unit, so we need to do the unit conversion by plussing 273. For the inlet temperature, we can get 300 Kelvin. For the outlet temperature, we can get 350 Kelvin. So referring to the table, the temperature under 300 Kelvin will get the enthalpy is 300.90 kJ per kg. For the outlet, we'll get the 350.27 kJ per kg for the outlet enthalpy. However, I will rearrange the equation again to make myself easy to get the answer. Now I will check the item to see that I got enough information or not. For the QR, I already obtained. For the mass flow rate, I already obtained. For the enthalpy, H2 and H1, I also already obtained. For the V1, I also already obtained. However, I don't have the V2, which is the item that I need to find. After substituting all the respective value, we can get the velocity as it is 62.8 m per s. This is the final answer. Now we can move to part B, which is determine the axis pressure. The axis pressure can be determined by using the formula of mass flow rate. The formula of mass flow rate is density multiplied with the volumetric flow rate, which is the equation number 1. As we need to determine the axis pressure, so we need to replace the density with the formula pressure divided by the gas constant multiplied with the T. However, for the volumetric flow rate, we can replace by the area multiplied with the velocity. Then we can simplify the equation and rearranging it again, so we can obtain the equation number 3. As we need to obtain the gas constant, we can referring to the table A1. So we obtain the gas constant for A is 287 joule per kg Kelvin. So after substituting all the value we obtain, so the axis pressure will be the 125.80 kilopascal. Thank you for watching our video. Hope you guys enjoyed it and learned a lot from this video.